Bismillahirrahmanirrahim. This is video about application of differentiation involve related weights. This is topic related weights or rate of change in calculus. Is the problem how to find the weight at which some quantity is changing by relating the quantity to the other quantities whose rates of change are known. So here is the strategy for solving the related weights problem. Step 1, we will draw a diagram if possible. Step 2, assign and label the figure. Step 3, find an equation that relates the variable. Step 4, use implicit or chain rule to differentiate the equation with respect to t, and then we will solve the unknown rates of change. Look at this example. This is the question involve related weights problem. The radius of a semicircle is increasing at the rate 6 cm per second. Calculate the rate of change in the area of the semicircle when the radius is 11 cm. So look here, our figure for this question is semicircle. So draw the semicircle. Here is the semicircle, and then we have radius. So radius for semicircle is here. Let's put the variable r is referred to radius, and then given for this question, the radius of semicircle increasing at the rate of 6 cm per second. So there are changing of radius, and given the changing of radius is 6 cm per second. So we can write 6 cm per second. If the changing of the radius, so we will write dr. D is the differentiation or changing of the radius, where we refer r is the radius. So dr is the changes of radius, and then the changes of something or radius will be referred to their time. So we write dt. dr per dt means the changing of radius at any time t. So the changing of radius is equal to 6 cm per second. Then the question wants us to find calculation rate of change in the area of the semicircle. So we want to find the changes of area. Let's say we put variable for area is A. So we want to find the changes of A. So we will write dA. dA is referred to the changes of area. So when we want to find the changes of area, it must be referred to their time. So we write dA over dt is referred to the changes of area at any time t for the semicircle. So we want to find dA over dt, the value of dA over dt. We want to find dA over dt when the radius is 11 cm. So to solve this one, we will use a chain rule. For question dA over dt, we will formulate a chain rule. We will separate into two parts. First, we will put dA and then dt at the last part dt. For this question, we have function dr, so we will put at the chain rule function dr here and dr here. So then if we cancel dr, then we will get back dA over dt. So now we want to find dA over dr. We will formulate formula area for semicircle. Formula area for semicircle is equal to 1 over 2 pi r square. So from here, we can differentiate function a with respect to r. So dA over dr, differentiate 1 over 2 pi r square, we get 2 over 2 pi r is equal to pi r. So now we substitute dA over dr into our chain rule. dA over dt will be equal to d over dr, we get just now pi r, multiplied by dr over dt, just now given from the equation, dr over dt is 6. And then we want to find the changes of area when radius is 11 cm. Means r is equal to 11. So we will substitute our r here is equal to 11 multiplied by 6. So now we get 66 pi. So the changes of area dA over dt is equal to 66 pi. Then our unit just now is cm per second. So dA area must be cm square over second. Next example, we have a cuboid has a square base and its height is 4 times its sides. So we have cuboid here with the square base, means if the side is x, so the other side is x, and their height is 4 times its sides, means the height is 4x. Then given the side increases at a rate of 0.03 cm second negative 1. So we can write 0.03 cm second negative 1 is the changing of side. So we put side here is x, means 0.03 is the dx, the differentiation of x, or changing of the side. So the changing of side must be referred to their time. So we will find dx over dt. So dx over dt here is 0.03. Then find the rate of change in volume. So we need to find changing of volume. So we will write dv. dv respect to their time, dv over dt. So now we need to find what is the value of dv over dt. And also given the changing of volume when the surface area is 288 cm square. So now we need to formulate dv over dt by using chain rule. So we will separate dv over something multiplied by something over dt. So here we have a function dx. So we can put function dx in the chain rule, dx and dx. Alright, so now we need to find function dx, dv over dx. So we can use information given. The surface area is 288 cm square. So we can formulate a formula surface area. Surface area for this cuboid is equal to 288. So we need to create a surface area for cuboid. So here, first we find the surface area for base is x square. So we have 2 base and top, so we have 2x square, and then plus for the side is 4x multiplied by x, and then we have 4 sides, means this one will be multiplied by 4. So the area formula will be equal to 2x square plus 4 multiplied by 4, 16. 16 x square. So formula for area is 18 x square. As our area just now is equal to 288, so we can equate 18 x square is equal to 288. So now we can calculate x by using calculator. Then we will get x square equal to 16 and x is equal to 4. It means we will find the changing of volume when x equal to 4. Then to find dV over dx, we can formula volume. Formula volume for cuboid is equal to 4x cubed. So from here we can differentiate function v respect to x. dV over dx is equal to differentiate 4x cubed is equal to 12x square. Then we can substitute x equal to 4. So 12 multiplied by 4 square. So dV over dx equal to 192. Then substitute into our formula dV over dx, 192 multiplied by dx over dt is 0.03. Then we get the answer is 5.72. So this is the changes of volume. The unit is, just now our unit is cm, so dV unit for volume must be cm cube second negative 1. Next example, we have a water is poured into a conical container with 30 cm in diameter and 20 cm height at a rate of 44 cm cube per second. Find the rate of change in the water level when the water level reaches the height of 7 cm. So our figure here is conical with the diameter 30 cm and the height is 20 cm. And here we have a rate of 44 cm cube per second. 44 cm cube per second means the changings of volume referred to our unit cm cube must be the changing of volume. So we can write dV. V is referred to the volume, and we will write dV over dt is referred to the changing of volume with respect to their time. Then we want to find the rate of change. Find the rate of change of water level. Let's say we put the water level with the variable h. So we want to find dh, the changing of height, dh over dt. What is the value of dh over dt? And also given the information when the height is 7 cm. So we can formulate dH over dt by using chain rule. So we put dH over something multiplied by something over dt. We have function dv here, so we will put dv into the chain rule. So to formulate formula dH over dv, we can start from the formula V, or volume for cone is equal to 1 over 3 pi r square h. We want to find dH over dv, or dv over dH from this equation, but here we have a variable r, or radius, so we need to change variable r into variable h. We can make a ratio with radius and height. If r divided by h will be equal to, we look here, our radius is 30 cm, so we can find radius is equal to 30 divided by 2 is 15 cm. So we have radius for this cone is 15 over height is 20. So from here we can get r. R will be equal to 15 over 20 is 3 over 4. 3 over 4 h. So now we can substitute into formula volume. Volume V equal to 1 over 3 pi r square, then substitute r is equal to 3 over 4 h square multiplied by h. So simplify, V will be equal to 3 over 16 pi h the power of 3. From here we can differentiate function v respect to h. So we can get dv over dh equal to, differentiate 3 over 16 pi h the power of 3, we will get 9 over 16 pi h the power of 2. Just now our chain rule need to find dH over dV. So from here we can get dH over dV will be equal to 16 over 9 pi h square. Then dH per dt will be equal to dH per dV. So substitute dH per dV is 16 over 9 pi h square multiplied by dv per dt, just now we have 44. Simplify this one, we get 704 over 9 pi h square. Then we will substitute h. Just now the question give information height is equal to 7 cm, so we will substitute h equal to 704 over 9 pi h is equal to 7 square. Then calculate this one, we will get dH over dt is 0.5081. Their unit according to our question just now is cm, so dH per dt, their height will be cm per second.